The distance between two peaks of a wave equals the wavelength in meters. We'll do an experiment based on this definition. You can try it with free software and a mic. Pay attention that the frequency and the wavelength can be completely different. For example, the speed of sound, while the frequency is constant in different media, is different. This causes the different values of the wavelength. As you know, the formula for the wavelength is, and if we measure the wavelength, we can calculate the sound speed simply. The method we'll explain during the video is not accurate enough, but gives an approximate number. You need this simple setup to measure the wavelength. Measurement microphone to the first mic input, and connect the second mic input to the sound card output or front speaker output. Open REW and choose these windows. You should reduce the volume of the left channel or the sound card output. I use Equalizer Apo to do this. Set the frequency at 1000 Hz. The blue wave is the measurement microphone, and the yellow is the sound card output. Put the speaker and the microphone on the carpet in the room. Now move the mic on a horizontal line to see a 180-degree phase difference between the two waves. Measure the distance between the mic and the speaker. Write this value down. Now move the microphone to see the 180-degree phase difference for the second time. You should adjust the sound volume of two waves during the experiment. We've done two 180 degrees. If we subtract the distances obtained by the blue wave from each other, it essentially matches the definition of wavelength, because wavelength is the distance between two identical repetitions. After all steps, you can calculate the sound speed based on the obtained numbers. Thanks for watching.